Abu Hassan ibn al-Haytham 965-1040 CE. Abu Ali Hassan ibn al-Haytham was one of the most eminent physicists, whose contributions to optics and the scientific methods are outstanding. Known in the West as al-Hazan, Ibn al-Haytham was born in 965 CE in Basra, and was educated in Basra and Baghdad. Thereafter, he went to Egypt, where he was asked to find ways of controlling the flood of the Nile. Being unsuccessful in this, he feigned madness until the death of Caliph al-Hakim. He also traveled to Spain and, during this period, he had ample time for his scientific pursuits, which included optics, mathematics, physics, medicine and development of scientific methods, on each of which he has left several outstanding books. He made a thorough examination of the passage of light through various media and discovered the laws of refraction. He also carried out the first experiments on the dispersion of light into its constituent colors. His book Kitab-آل Manadhir was translated into Latin in the Middle Ages, as also his book dealing with the colors of sunset. He dealt at length with the theory of various physical phenomena like shadows, eclipses, the rainbow, and speculated on the physical nature of light. He is the first to describe accurately the various parts of the eye and give a scientific explanation of the process of vision. He also attempted to explain binocular vision, and gave a correct explanation of the apparent increase in size of the sun and the moon when near the horizon. He is known for the earliest use of the camera obscura. He contradicted Ptolemy and Euclid's theory of vision that objects are seen by rays of light emanating from the eyes. According to him, the rays originate in the object of vision and not in the eye. Through these extensive researches on optics, he has been considered as the father of modern optics. The Latin translation of his main work, Kitab-آl Manadhir, exerted a great influence upon Western science, e.g. on the work of Roger Bacon and Kepler. It brought about a great progress in experimental methods. His research in catoptrics centered on spherical and parabolic means. He made the important observation that the ratio between the angle of incidence and refraction does not remain constant, and investigated the magnifying power of a lens. His catoptrics contain the important problem known as al-Hazan's problem. It comprises drawing lines from 2 points in the plane of a circle meeting at a point on the circumference and making equal angles with the normal at that point. This leads to an equation of the 4th degree. In his book Mizan al-Hikmah, Ibn al-Haytham has discussed the density of the atmosphere and developed a relation between it and the height. He also studied atmospheric refraction. He discovered that the twilight only ceases or begins when the sun is 19 degrees below the horizon, and attempted to measure the height of the atmosphere on that basis. He has also discussed the theories of attraction between masses, and it seems that he was aware of the magnitude of acceleration due to gravity. His contribution to mathematics and physics was extensive. In mathematics, he developed analytical geometry by establishing linkage between algebra and geometry. He studied the mechanics of motion of a body and was the first to maintain that a body moves perpetually unless an external force stops it or changes its direction of motion. This would seem equivalent to the first law of motion. The list of his books runs to 200 or so, very few of which have survived. Even his monumental treatise on optics survived through its Latin translation. During the Middle Ages, his books on cosmology were translated into Latin, Hebrew, and other languages. He has also written on the subject of evolution, a book that deserves serious attention even today. In his writing, one can see a clear development of the scientific methods as developed and applied by the Muslims and comprising the systematic observation of physical phenomena and their linking together into a scientific theory. This was a major breakthrough in scientific methodology, as distinct from guess and gesture, and placed scientific pursuits on a sound foundation comprising systematic relationship between observation, hypothesis and verification. Ibn al-Haytham's influence on physical sciences in general, and optics in particular, has been held in high esteem and, in fact, it ushered in a new era in optical research, both in theory and practice.